Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now it takes many billions of years to create a galaxy like the Milky Way. Our knowledge of the universe grows a lot every year, as scientists all over the world make amazing discoveries that change what we know. Today, we're going to talk about some of the newest and less well-known discoveries that even the most experienced experts can't figure out. Join us as we explore the depths of space and find secrets that help us get closer to solving some of the most important questions in the universe. Imagine that a planet was found in the outer parts of our solar system that follows its star backward compared to other planets. Not only would such a find be interesting, but it would also call into question current ideas about how planetary systems form. Researchers have recently found some of these strange exoplanets. For example, some orbit their stars in very close orbits, which makes the surface very hot and able to melt metals. Others are rogue planets that wander through the galaxy without a star. This makes people wonder where they came from and how they stay alive in the harsh environment of space. Understanding the complexities of these mysterious heavenly bodies greatly expands the field of science. This has effects on both academic interest and practical issues, such as how we might live on other worlds in the future. Each new finding is a key piece in putting the big puzzle of the universe together. Think about what it would mean to find water vapor on a faraway world or to find a planet with an atmosphere like Earth's. These results could show where conditions are right for life to start, which could help plan future trips to these faraway places. Understanding the unique shapes and behaviors of these planets also helps scientists improve their models of the structure and development of the universe. This gives us clues about the past and future of Earth. Imagine that we find an exoplanet whose path isn't smooth, which goes against current theories of gravity and makes us question what we think we know about physics and how things move in space. Not only is this kind of information useful for school, but it will also have long-term effects on technology and space research. The finding of 27 or 10, the largest world in our solar system that hasn't been named yet, is an interesting case study in how to find and study celestial bodies. This faraway object, which is in the scattered disk region beyond Neptune, gives astronomers both new tasks and chances. Astronomers found 27 or 10 for the first time while using the Samuel telescope at Palmer Observatory for a regular check. It was confirmed to have been found by looking at pre-discovery pictures made by the Spacewatch project. This shows how space science is often collaborative and like a detective story. 27 or 10 is the third largest known dwarf planet in our solar system. Its diameter is about 1,535 kilometers, which makes it a very big planet. Even though it is very big, it doesn't have a name yet because we don't fully understand its orbit and haven't been able to figure it out enough to meet the International Astronomical Union standards for naming objects. Its surface is mysteriously dark and red, which suggests that it contains complex organic compounds called tholin. These are made when sunlight hits simple organic compounds like methane and ammonia. Did you know that despite its vast size, 27 or 10 remains unnamed because its orbit has not been determined with enough accuracy to grant it a formal name? Its dark surface and slow rotation make it one of the solar system's most elusive objects. The study of 27 or 10 includes both direct observations and computer models that try to guess its path and figure out what its physical properties are. To gather information, astronomers use both telescopes on the ground and platforms in space, such as the Hubble Space Telescope. The light curves from these observations help us figure out its unusually slow rotation period. It takes about 45 hours to finish a rotation, making it one of the Kuiper Belt objects that rotates the slowest. Just when you thought we knew everything there is to know about our solar system, discoveries like 27 or 10 come along to challenge our perspectives. But hold on, What we discover next about another distant celestial body might just redefine the impossible. This introduction to 27 or 10 not only sets the stage for a deeper look into strange celestial bodies, but it also shows how we are still finding new things in the outer solar system. Every piece of information we get helps us learn more about these faraway worlds and the universe as a whole. Ultra-hot Neptunes are an interesting group of extrasolar planets that don't behave like normal planets. These objects in space circle very close to their stars, much closer than Mercury does to our Sun. This means that the surfaces of these objects can get very hot, over 1,700 degrees Celsius 3,092 degrees Fahrenheit. Being so close to their host stars challenges what we think we know about how planets form and how they stay alive, because it can lead to atmospheric blow-off, when the atmosphere is actually ripped away by the radiation and winds of the star. Take for example KLT9b, a very hot Neptune that is so hot that molecules, like water, can't form, and instead break down into atomic hydrogen. Observing these planets not only tests what we think we know about atmospheres, but also how well our existing models of categorizing planets work. Extreme conditions bring up important questions about the variety and strength of planetary systems all over the world. If you compare ultra-hot Neptunes to other types of planets, what do you think the reasons are for their scarcity? It might have something to do with how they formed and the conditions that had to be met to make such harsh settings. Are you interested in the secrets of 27 or 10? Just wait until you hear about I-13 to 4134. What scientists found around this very large star could be the key to figuring out how celestial giants form. This change from talking about very hot Neptunes to talking about I-13 to 4134 suggests that we will continue to look into the strangest and most extreme things in the universe. Each topic builds on the previous one, focusing on the new discoveries and surprises that keep happening in science and make us question what we think we know. I-13 to 4134 is a very big star in the very deep parts of the constellation Centaurus. A new study of this star has shed new light on how complicated star formation is. This huge cosmic body, which is about 20 times the mass of our Sun, has called into question the idea that big stars are usually made when smaller stars crash into and merge with each other. Instead, the finding of a large disk of gas and dust orbiting I-13 to 4134 suggests that even the biggest stars might form in the same way that smaller stars do, by slowly gathering matter from a protoplanetary disk. Such a result has very important effects. It's not just a flattening nature. The disk around I-13 to 4134 is moving and full of complex biological molecules and dust particles that interact with each other as the star's gravity pulls them together. Even in these harsh conditions, this interaction could cause planets to form, which could mean that scientists can look in more places for new worlds and maybe even life. Astronomers can improve their models of how stars grow and change over time by learning more about the disk's properties. Together, I-13-4134's strong brightness and the gravitational pull of its mass make it a unique place to study how matter acts in some of the galaxy's most energetic areas. This study is very important for both mapping out the life cycle of stars and looking into the possibility of planets forming in places that were thought to be too unfriendly before. Our next topic is rogue planets, which includes both the exciting environments of big stars like I-13 to 4134 and the mystery planets that wander the universe. These mysterious bodies, which float in space without a star to circle around, make us think about what a planet is and where they can live. Rogue planets are both mysterious and instructive. They are a new frontier in our search for knowledge about the universe. What do you think would happen to a planet that isn't held in place by the gravity of a star? We'll find out with our next subject, which is rogue worlds. We move from talking about huge star systems like I-13 to 4,134 to rogue planets, or free-floating planets. This is very different from the usual idea of planets as things that circle stars in a clear solar system. These strange space travelers aren't held back by the gravity of any star, so they move through the sky by themselves. Their finding goes against the usual ideas about how planets form, which say that the gravitational pull of the star is needed to gather and shape planetary bodies. Rogue planets are thought to form in one of two ways. Either they are thrown out of their home solar systems by gravitational pulls, or they form on their own in a cloud of stars that are still growing but never join with a star. Rogue planets are especially hard to find, and methods like microlensing are often used to find them from Earth. This happens when the rogue planet briefly shines brighter than a faraway star as it passes in front of it. These events are rare but useful chances to learn more about the features of these wandering planets. Planets that go off course have huge effects on our understanding of the universe. They show that planetary systems may be more complex and changing than we thought, and that the right conditions for planet formation can happen in more situations than just those where planets circle stars. Also, the sheer number of these rogue planets suggests that they may outnumber the stars in our galaxy. Studying them gives us more than just details about strange places in the universe. It can also help us learn more about the most essential features of stars and how planetary systems change over time. The observation of these rogue worlds is just one of the ways that today's space scientists are pushing the bounds of knowledge, asking questions that have been known since the start of time. In closing, it's clear that the field of astronomy is constantly evolving. New discoveries challenge what we think we know about the universe, from the formation of planetary systems to the behavior of stars. As technology improves and our methods become more sophisticated, our understanding of the cosmos deepens. These insights not only expand our scientific knowledge, but also inspire us to continue exploring the mysteries of the universe.